Hi boys and girls, today we're going to focus on geometric solids. So a geometric solid is a three-dimensional figure. So there's two-dimensional figures and three-dimensional figures. So this triangle here is an example of a two-dimensional figure because it is just long and wide, but there's no height to it. And that's the difference between a two-dimensional figure, a surface, and a solid. So these solids are three-dimensional and they all have a length, a width, and a height. They can be long, they can be wide, and they can be high. And that's how they're three-dimensional. Or you can also say 3D. So let's just look at some of the names of these, and then we're going to focus on faces, edges, and vertices. We'll talk more about that later, but for now, let's look at this one over here. We know that this one is called a cylinder. Actually, let's look at the cylinder right now. A cylinder, well, it's obviously long, it's wide, and it's high, so it's three-dimensional. And let's look at how many faces it has. A face is a flat surface. So this cylinder over here has two faces. Face, face. So two faces in a cylinder, but it does not, so this is curved. Over here it's curved, so this is not considered a face. So a face has to be a flat surface. So it's a cylinder, it has a face, and an edge. An edge here, it has a curved edge, and another edge over here. It does not have any vertex, a corner, and it does not have vertices. So a vertex is one, and vertices is more than one. It could be two or three. Then we have a cube. So a cube, let's count together how many faces, how many edges, and how many vertices. One, so it's a face, one, two, I'm not moving it, 3, 4, 5, 6. So it's got 6 faces, and remember we said a face is a flat surface. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. And how many vertices? Hold it in place, don't move it or you'll get confused. 1, 2, 3, 4, 5, 6, 7, 8. So 8 vertices. So remember, vertices, it's a corner. Let's do this one. This one's a cone. A cone. So let's count the faces. Remember, a face is a flat surface, so a cone has one face. And it has a vertex. Here it is. This is not considered a face because it's curved. Let's look at this one. This one is a square-based pyramid. Let's count the faces. 1, 2, 3, 4, 5 faces. And now let's count the edges. 1, 2, 3, 4, 5, 6, 7, 8 edges. And let's count the vertices. 1, 2, 3, 4, 5. Let's look at this one over here. This one is the ellipsoid. A lot of people get confused between the ellipsoid and the ovoid. The ovoid is the one that looks like the egg. This is the ellipsoid. So the ellipsoid has no faces. There's nothing flat. It's in a flat surface, so 0 faces, 0 edges, and 0 vertices. 0, 0, 0, pretty simple with that one. Let's go to the ovoid. The ovoid, again, the one that looks like the egg. 0 faces, 0 edges, 0 vertices. Sphere. The sphere, it's like the ball. 0 faces, 0 edges, 0 vertices. This is, if it's standing like this, it's a square-based prism. If it's like this, you could call it a rectangular-based prism. It depends on where or how it's positioned. But let's look at this. I'm calling it the square-based prism. So again, let's count the faces. 1, 2, 3, 4, 5, 6 faces. Remember, a face is a flat surface. Let's count the edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And let's count the vertices. 1, 2, 3, 4, 5, 6, 7, 8. We're going to stop it there. I just want to show you this chart because this chart is very similar to the sheet that I want you to fill out this week. So you have to name the solid. You have to count the faces, count the edges, and count the vertices. Remember, the face is the flat surface. The edge could be a straight edge or it could be a curved edge. And a vertex is the corner, or if it's more than one, we call them vertices.